Hello. Well, welcome to the next presentation in the trigonometry modules. Just to start off a little bit, let's review what we've done so far. In the last couple of modules, we learned the definitions, or at least I guess we could call it a partial definition of the sine, the cosine, and tangent functions. And the mnemonic we used to memorize that was SOHCAHTOA. Let me write that down. SOHCAHTOA. And what that told us is, let's say we had a right triangle. Let me draw a right triangle. Whoops. Right triangle. And this is the right angle here. This is the hypotenuse. So let me just write. Let me label the hypotenuse H. Let me label this, and let's put this. And say we want to figure out, we want to use this angle right here, theta. We'll call this theta, whatever. Then this is the adjacent side. And this is the opposite side. And that's an O. And so tells us that sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. Now that, I think by this point, and especially if you did some of the exercises on the Khan Academy, that should be second nature and should make a lot of sense to you. But this definition, using a right triangle like this, actually breaks down at certain points, actually at a lot of points. For example, what happens as this angle right here approaches 90 degrees? And you can't have two 90-degree angles in a right triangle, can you? Then it would be like a rectangle or something. But you can actually probably figure out what happens as it approaches 90 degrees. But this definition breaks down for that. Also, what happens if this angle is negative? Or what happens if this angle is more than 90 degrees? Or what happens if it's 800 degrees, or 8 pi radians? Not that 800 and 8 pi radians are the same thing, but obviously this definition starts to break down because we couldn't even draw a right triangle that has those properties. So now I'm going to introduce you to an extension of this definition. It's really the same thing, but it allows the sine, the cosine, and the tangent functions to be defined for angles greater than or equal to pi over 2, or 90 degrees, or less than 0. So let's draw a unit circle. So this is just the coordinate axis, and here is a circle of radius 1. And let me see. Let me make sure I'm using the correct pen tool. Okay. So let's call this right here. So this is theta. This is an angle, right, between this line, between kind of the x-axis and this line I just drew here. And this is a radius, right? And we said that this has a radius 1. So the length of this line is 1, right? Because it just goes from the origin to the outside of the circle. So it has a radius of 1. And now I'm going to draw a right triangle again. So let me just drop a line from here. So there, I have a right triangle. So if we use the old definition we learned before, let's just focus on sine for now. So sine is equal to opposite over hypotenuse. Let's apply that to this right triangle right here. This is the right angle. So what's the opposite angle of this? What's the opposite side from this angle? Right, I'm going to change to yellow. It's this side, right? This is the opposite side. And what's the hypotenuse? The hypotenuse is just this radius, right? And let's just say that this point where it intersects the circle, let's call this point right here. Let's call this point x, comma y, right? So what's the height of this opposite side? Well, it's y, right? Because it's just the height of that point. This is of height y. So sine of this angle right here, sine of theta, is going to equal the opposite side, which is this yellow side, which is just the y coordinate, is going to equal y over the hypotenuse. The hypotenuse is this pink side here. And what's the length of the hypotenuse? Well, it's the radius of this unit circle. So it's 1. And y divided by 1, well, that's just y. So we see that sine of theta is equal to y. Let's do the same thing for cosine of theta. Well, we know that cosine is equal to adjacent over hypotenuse. Well, what's the adjacent side here? I'm running out of colors. Right, the adjacent side is this bottom side right here. So that would equal, so if I said, I'm running out of space too, cosine of theta would equal this gray side, which is the adjacent side. And what is that? What is this? What is this length? What is the length of this side? Well, it's just x, right? If this is the point xy, then this distance here is x, and we already learned this distance, or we already observed that this distance is y. So this distance being just x, we know that the adjacent length is x. So we say cosine of theta is equal to x over the hypotenuse. And once again, the hypotenuse is 1. So cosine of theta is equal to x. I know what you're thinking. Sal, that's very nice and cute. Cosine of theta equals x, sine of theta equals y. But how is this really different from what we were doing before? Well, if I define it this way, now all of a sudden, when the angle becomes, let's say, 90 degrees, let's say this is, now I can actually define what sine of theta is. Sine of theta now is just y, is just the y coordinate, which is 1. If theta is equal to, I'm going to make sure it's very messy right here. If theta is equal to 90 degrees, or pi over 2 radians. Right, this is pi over 2. This angle right here. Right? And similarly, cosine of pi over 2 is 0, because the x coordinate right here is 0. Let me do it with a couple more examples. Oh, I'm forgetting the tangent function. And you could probably figure out now, what is the definition now we can use for the tangent function? Well, going back, let's use this green theta here because it's kind of a normal angle. So in this green theta here, tangent is opposite over adjacent. So tangent now we can define as y over x. And remember, these y's and x's that we're using are the point on the unit circle where the angle that's defined by this, by whatever, where the radius that is subtended by this angle, or I guess the arc, intersects. Actually, I'm getting confused with terminology. It's where this line intersects the circumference. The coordinate of that, the sine of theta is equal to y, the cosine of theta is equal to x, and the tangent of theta is equal to y over x. Let's do a couple of examples, and hopefully this will make a little bit more sense to you. Let me try to really fast draw a new unit circle. So that's my unit circle. And here's the coordinate axis, was one of them. And here is the other one. So let's get an example like, so if we use the angle, let's use the angle pi over 2, right? Theta equals pi over 2. Well, pi over 2 is right here, right? It's a 90-degree angle if you wanted to use degrees. And now we just figure out where it intersects the unit circle. And once again, this is the unit circle, so it has a radius of 1. So we can see that sine of pi over 2, it equals the y coordinate where it intersects the unit circle. So that's just 1. What's cosine of pi over 2? Well, it's just the x coordinate where you intersect the unit circle, and the x coordinate here is 0. And what's the tangent of pi over 2? This is interesting. The tangent of pi over 2. Well, the tangent we defined now as y over x. So the y coordinate, this is the point 0, 1, right? The y coordinate is 1. So it equals 1 over 0. Yep. So this is undefined. So still, we don't have a tangent function that can define itself at certain points. But in the next module, we're actually going to graph this, and you'll see that it approaches infinity. And similarly, we could try to find the functions for when theta equals pi, right? That's like 180 degrees. That's this point right here. So sine of pi, what's the y coordinate at this point? Well, this point is -1, 0. So the y coordinate is 0. What's the x coordinate? Cosine of pi, that's -1. And of course, what's the tangent of pi? Radians. It's y over x. So it's 0 over -1. It equals 0. Hopefully this makes sense. Now in the next module, I'll actually graph these points, and you'll see I guess how it all comes together and why it is useful to define the sine, the cosine, and tangent functions this way. See you soon.